Hello, geometry. We're going to skip 5.3 for now. We'll come back to it because 5.4 is just way more relevant. So 5.4 is all about isosceles triangles, all right? So let's talk about the parts of an isosceles triangle. We know how to name them, first of all, right? We've got two congruent sides, so it's an isosceles triangle. We know that. These sides that are congruent are called the legs, all right? They're called the legs. And then up here, this is called the vertex angle, all right? It's the vertex angle. Now, opposite that vertex angle, so down here is what we call the base. And then this in here, so that guy and that guy are the base angles. And the reason we need to know this is because we're going to be talking about what's special, not only about the legs. We know for isosceles triangles that these legs are congruent, but also about this vertex angle and these base angles. All right, they tell us some things that can be really, really handy. So, base angles theorem. This says if two sides, all right, if two sides of a triangle are congruent, then the opposite angles are congruent. So that means like this. All right. So this is saying that if AC is congruent to AB here, right, if they're congruent, then angle C is congruent to angle B. All right? Of course, C is congruent to C. But in this case, it's saying B, all right? So if these are congruent, then the opposite angles are also congruent. That's the base angles theorem. Now the converse, remember converse is where we just flip them around. This is why we learned all of those logical statement terms back in the chapter 2. It was because we are just going to reverse that. So instead of it's if two sides are congruent, now it's going to be if two angles are congruent, then the opposite sides are congruent. So in this case, if we have that angle C is congruent to angle B, that means that AB is congruent to AC. Ooh, don't forget your hats. I forgot hats on those, my bad. I was so into how cool this is. All right, so if our angles are congruent, then it implies that our sides are congruent, our opposite sides are congruent, and vice versa. So this is really, really powerful, this base angles theorem and converse of base angles theorem. So I'm going to move that to the side for a second, and we're going to look at how we can apply this. So we want to find each missing measure. So we want to find the measure of angle J and the measure of angle K. We already know that the sides are congruent. Well, because of that, that means that our opposite angles are congruent. So that means that angle J is congruent to angle L. So angle J must be 68 degrees. And it's all because of the base angles theorem, right? We know our sides are congruent, therefore our angles will be congruent. We still need to figure out what the measure of angle K is. We have to think back to what we just talked about in 5.1, which was that all of these angles will add to make 180. So angle J plus angle L plus angle K equals 180. And we know we've got 68 plus 68 plus angle K is equal to 180. So that's 136 plus K equals 180. If I subtract 136 on both sides, we get angle K is equal to 46. So this is 46 degrees. All right, so this one right here, measure of angle C. We already know that our sides are congruent, so we know that this is isosceles, which means that if you know it, mark it, angle C and angle E must be congruent. So angle C must be congruent to angle E because it's an isosceles triangle, and those are the base angles. We know that angle D is 106, so angle D plus angle E will equal 180. And I'm just going to pick a variable to represent the measures of angles C and E. I'm going to go with X because I'm lame. So angle D plus X equals 180. Well, angle D, I can really fill in 106. And now I just want to solve for my X. So I need to subtract 106 on both sides. So I'm left with 74. And then X plus X is really 2X. When I divide everything by 2, I end up with an x is equal to 37. So both of these have a measure of 37. All right, so for problem number 3 here, I know that angle x is 77 and angle z is 77. That means these angles are congruent, right? They're exactly the same, they're congruent. So I know something about their opposite sides. If you know it, mark it. So yx is going to be congruent to yz. Yx is 12, that means yz is going to be 12 as well. And then I need to figure out the measure of angle y up here. So that means angle x plus angle z plus angle y is equal to 180. So we really have 77 plus 77 plus angle y is equal to 180. So that's 154 plus angle y is equal to 180. When I subtract 154 on both sides, I get angle y is equal to 26. All right, I'm going to slide this up. So we want to find the value of each variable. Again, this is really important that you know what is congruent and which theorem you're using. So in this case, we know that our sides are congruent, therefore we're using base angles theorem. So we're going to set this up, and there's no setup in terms of letters, right? We're just making them equal and solving. So we've got 5x equals 8x minus 30. And then I need to solve for my x from there. 5 is exactly the same. I'm going to subtract 5x. So we get 9 equals 3x minus 30. I need to add 30. So we get 39 equals 3x. When I divide everything by 3, I get 13 equals x. So for this one down here, we've been given that we have an angle of 74 and an angle 74. Those are congruent. Therefore, we know that our sides are also congruent. So we have 3x plus 23 is going to be equal to 9x minus 73. And you want to solve for your x. Very similar thing with number 7. So I'm going to jump over to number 8. All right, I encourage you to practice those. Take a minute to practice them, but the next one we'll do is 8. All right, in triangle RST, first of all, draw a picture. RST. If RT is congruent to ST, and the measure of angle R is 9x plus 2, so 9x plus 2, the measure of angle S is 13x minus 18, and the measure of angle T is 17x plus 1. Find x and the measure of each angle. Okay, first of all, if you did not have your picture, you would have no idea which angles are your base angles, right? Our base angles are angle S and angle R. That means they are congruent to each other. That is your setup, all right? You have to write that because you've been given points. So we have to write angle S is congruent to angle R. Now I can fill in and I can solve. So 9x plus 2 is going to equal 13x minus 18. I'm going to subtract 9x on both sides. So I get 4x minus 18 is equal to 2. When I add 18, I get 20 is equal to 4x. When I divide by 4, we end up with an x is equal to 5. So I figured out what my x is, it's 5. Now I have to figure out each angle. So angle S is equal to 13x minus 18. So when I plug in my 5, I get 13 times 5 minus 18. 13 times 5 is 65. 65. And when I subtract 18, we end up with 47. Now here's the cool thing. Because S is equal to R, I know that angle R is also 47 degrees. So I don't have to plug it in. I can just write it. Which means I just have to figure out the measure of angle T. So angle T is equal to 17 times 5 plus 1. 17 times 5 is 85. Plus 1 is 86. It's not quite a right triangle, but close. All right, on our last page here, there are even more for you to try out. Again, I cannot encourage you enough for these ones up here for you to draw a picture. So if it says triangle DEF, give yourself a little DEF and mark it. So this one is saying that angle D, which is this one, is congruent to angle E, right? Mark it, mark it, mark it, mark it. Same thing with this guy. This is a triangle WXY. So try it out for yourself, then check my answer key. And then down here, again, you are trying to solve, all right? You're trying to solve. I will tell you now that for these ones, and we can do one of these together. For these ones, it's pretty similar to what we've already done, right? But for these ones, it's really, really helpful to think about what these angles must be. So you know that you have 104 plus 9x. Actually, I'm going to just change this. No, I'm not. 9x minus 25. You know that this angle and this angle are congruent. So 9x minus 25. And that's going to be equal to 180. All right. So we're subtracting 50 from this guy. I'm sorry. I'm trying to do math out loud and in my head. Let me rephrase. When I combine my like terms, I've got 9x plus 9x gets me 18x. 104 minus 25 gets me positive 54. I have to subtract 54 on both sides. So I end up with 126 equals 18x. When I divide 18 on both sides, I end up with an x is 7. So that is my x. All right. So mark what you know, and then because you know that this is congruent, you end up writing it twice. All right. I just wanted to point that out. Email me if you have any questions about this. I am happy to help anytime.